Hello, Professor. I'm Jing Xiang. Welcome to our video presentation of Long Sentinel. We are from P2A Group 5, which consists of me, Aoyu, Dylan, Hiong Kai, and Jay. This is Gary, our project mascot and resident flounder. He may look flat, but his role in our team is anything but flat. This is my teammate's email and our project links to Flan, our project. This slide is a quick overview of the content we'll be going through. Our project focuses on quantum-resistant protocols. Our quantum computing is no longer a distant concept. It's rapidly becoming a reality while it's still in early stages. Its potential to break modern encryption standards presents a significant cybersecurity threat. At Flong, we are committed to fortifying digital infrastructure against these emerging threats, ensuring a secure future in the quantum era. Next, I will talk about the problems of quantum computers. The vulnerability lies in our current digital infrastructure, which relies on encryption standards such as RSA and ECC. These cryptographic methods, while complex, are fundamentally based on mathematical problems that are quantum computers leveraging on short algorithms, which can be easily cracked. Attackers are already harvesting encrypted data today with the intent of decrypting once quantum capabilities advances. This is a threat known as harvest now, decrypt later. The real-world implications of quantum computing poses a severe risk to national security and global financial stability. With the ability to break encryption, quantum computers could expose state secrets, compromise military defenses, and undermine the integrity of financial transactions. This timeline highlights key breakthroughs in quantum computing, showcasing its rapid advancement and impending impact on the digital security. On January 8, 2019, IBM unveils the first circuit-based commercial computer. On May 9, 2023, IBM launches system Model H2 with a record quantum volume of 65,536, measuring qubit performance, error rates, and connectivity. Soon later on December 4, 2023 that year, IBM introduced Quantum System 2, a scalable quantum computer designed for future expansion. On the 9th of December 2024, we introduced Reload, capable of performing a benchmark computation under just 5 minutes, something that today's faster computer would take 10 septillion years to complete. On February this year, Intel partnered with Japan National Institute of Advanced Industrial Science and Technology to advance quantum computing. And just recently, on February 19 this year, Microsoft unveils Majorana 1, a palm-sized quantum architecture innovation. This milestone highlights the accelerating pace of quantum computing, reinforcing the urgent need for quantum-resistant protocols to safeguard our digital infrastructure. Next, I'll hand over my time to Aoi, who will be presenting on Flan and its design philosophy.
Okay, thank you, Jing Xiang. So, what is Flan, you may ask? Let me introduce you to Flan, our quantum-resistant protocol analyzer. Flan is a browser extension designed to scan websites for cryptographic vulnerabilities and prepare them for the quantum computing era. Quantum computers, while not yet mainstream, have the potential to break current encryption standards like RSA and ECC. Flan addresses this by identifying weak encryption methods and recommending quantum-resistant alternatives. So, our primary features include comprehensive scanning, which detects weak encryption protocols, certificates, and security flaws. Real-time analysis, which provides instant feedback on the security posture of a website. Lastly, we also have quantum-resistant suggestions, which recommends modern cryptographic solutions for future-proof systems. Flan is not just a tool, but a step towards a safer, more secure digital future. Now that you know what Flan is, let's dive into the design philosophy and methodology that makes it so effective. So first, our extension focuses on two very simple things, which are simplicity and minimalism. So for simplicity, our design philosophy it relies on keeping everything as simple as possible for the user, which removes unnecessary jargon and configurations, among other things. So this will prevent and deter people who might be confused with if you have a lot of options and stuff. So this makes it a lot easier and user friendly. So next, we have a minimalistic design to our extension. So what I thing this can do is it can further probe users to try our extension even if they are not interested. Users can also scan their websites with just a single click. Results are generated and are clear and simple to understand, which enables a low skill floor. The next two design philosophies that I've included was modularity and automation. So built with modularity in mind, this project allows easy integration and expansion with more scans and tools. So we have designed it in a very structured and simple way. So anyone can just come in and add modules or new scans into our tool. So we also plan to go open source. So this will encourage developers to join our mission. Next, automation. Our scanning is fully automated. So all you have to do is simply click scan, and then you'll automatically analyze the website's cryptographic protocols, certificates, and JavaScript code without requiring any technical expertise from the user. This makes it easy to use and also user-friendly at the same time. Next, for our methodology. So first was research and planning. So understanding how quantum computers work against cryptography was very important. Identifying the vulnerable cryptographic vulnerabilities and also researching on post-quantum cryptographic standards. So since a quantum computer is a very new field, so all this it took some time to find it. So next, prototyping. So we developed a basic browser extension prototype with core scanning functionality, and this focused on simplicity and ease of use during the initial design phase. Next, we went through a process of iterative development, which continuously refined the tool based on testing and feedback from our friends and classmates. We also added features incrementally to ensure stability and usability. Lastly, we also implemented testing and validation. So we tested Flaun on a variety of websites to ensure accurate detection of vulnerabilities. We also validated our results against known cryptographic standards and best practices. We developed our own website also to further confirm that our scans were accurate and also complete. Yes, now I'd like to pass my time on to Hong Kai.
Hi, I'm Hiong Kai. I'll be talking about the relevance of Flaun. Flaun is relevant for proactive security, even though quantum computers are not widely available yet. Preparing for their potential impact is crucial to ensuring long-term data protection. Flaun helps to ensure compliance as industry begins to adopt post-quantum cryptographic standards to stay ahead of the emerging threats. Flaun is especially important for sectors with zero tolerance for security risks such as military, government, and critical infrastructure. The long-term vision for Flaun is to be a versatile and free web extension that helps websites prepare for the eventual adoption of quantum computers. Flaun is designed for everyone, from small businesses to large enterprises, helping to prevent future breaches and data compromises by identifying vulnerable protocols today. Flaun plans to go open source to encourage widespread adoption. This open source approach will allow contributions and innovations from global cybersecurity community. So what sets Flaun apart? Flaun, unlike complex cryptographic tools, is easy to use, accessible to all, and most importantly, free. It focuses on detecting vulnerabilities before they can be exploited, providing proactive security. Flaun is the tool of the future, designed to prepare and address future threats, not just today's risks. I'll hand over the time to Jay.
Thank you, Hong Kai. So now I'll be talking about the future plans of Flaun and the limitation we face during this project. So our future plans in the long term is to firstly go open source, where we build a community and attract more users. Secondly, expanding Flaun's capability to include network and system level scanning. Thirdly, we aim to go beyond just being a browser extension due to its limited capabilities. Lastly, is to integrate with security tools to support SIEMs, firewall, and more. Our short-term plan are to launch Flaun as a browser extension with basic scanning capabilities and to partner with military and government organizations for pilot testing. Next, this is the result obtained from running Flaun on the website. The image on the left shows what the output will look like after the scan has been completed. As you can see, we scan the JavaScript, token, header, and certificate to look for any algorithm and determine if they are quantum resistant. Pressing the generate report button on the bottom right will generate the report as seen on the right. So now I will go on to demonstrate the slide, the project. Run the scan on the test website that we created, which include both safe and vulnerable JavaScript encryption and token. So first, you click on the extension button here and you click scan, and you wait a while, and as you can see, the JavaScript results. We found 10 encryption, six of them is safe, and 4 of them are vulnerable. And these are the vulnerable details. Same for the token. So now I will test the extension on the public website. Same thing, just click and click scan and wait a while. Yeah, and you can see the JavaScript we found 1 and they are safe. The token we found 2 and 2 of them are vulnerable. And for the headers, we scan mostly on the TLS version and the cipher suit. So these are the TLS version and cipher suit, they are vulnerable. And the certificate, and yeah. So we will try generating the report. You wait a while. After the report has been generated, you open, and you can see this is the first page with the report title and the cover page, the table content, and the introduction, which includes the scope and the purpose of the report. And this is the executive summary of the report. This is the vulnerability analysis based on the findings that we scan. This is the risk assessment based on the findings that we scan also. And this is the recommendation to fix the website. And the next step to implementing the quantum safe cryptography and the conclusion. So that's all for the demo. So now I'll go back to with the slides. So now I'll be talking about the limitation of the project. So there's no public safe website being made, as it is a relatively new concept. And there's no quantum safe certificate made, so we cannot implement them on our test website. And the quantum safe cipher suit are all in experimental phase, so we cannot implement on the website as well. So next, I'll pass on to Dylan, who will be talking about the artificial intelligence.
So thank you, Jay. Good afternoon. My name is Dylan, and I'll now go over the portion of artificial intelligence. So why did our team use AI to generate our reports? Well, we realized that AI report generation has brought about 3 key benefits to our project: efficiency, customization, and scalability. The AI has made our product more efficient by its capability to automatically analyze the data outputs from our scans to write a summarized report. Something that would take a humans hours to do will now take the AI seconds to complete. The use of AI has also allowed us to dynamically generate a fully comprehensive PDF report detailing the results from the scans, providing our end users with analysis insights and recommendations moving forward. With our implementation of AI, we are confident that our products will be able to handle large volume of data from the scan, ensuring scalability. Now, how else did the AI help us in our project? Well, firstly, we use Gen AI to help us brainstorm for project ideas based on the trends, interests, and urgency in the security industry. Next, we use AI to help with our programming and development, such as debugging, explanation, generation, and optimization of our codes. We also use AI to check on coding best practices. Next, We use AI to help with our writing, content creation, such as for grammar and spelling checks, formatting citations in IEEE, and enhancing the vocabulary and coherence of our report proposal. Lastly, we use AI for our creative aspects, such as the graphics designs, slide designs, and the automatic generation of subtitles for this presentation video. Now, before I wrap up the presentation, I would like to go over the overall workflow of our application. Let's begin with the application. Let's begin with the application directly scanning the website for cryptographic methods such as JavaScript encryptions and tokens. Next, the application will use SSL checker to scan the website for the certificate data. Thirdly, the application will use SSL labs to scan the cipher suites and the SSL and TLS version. So now, after all the scans are done, the application will process this data and check whether each of the protocols or methods used are quantum safe or vulnerable. It will then send this data to the Gemini's API to do the report content generation. This will then be sent back to the application to process and insert the output into a well-formatted PDF report, which will be seen by the end user. So, as I wrap up this presentation, I would like to emphasize the rapid advancement of quantum computing. It will render our traditional encryption methods obsolete. We all need to stay ahead of the curve and safeguard our digital assets against future threats. So scan your website today. It's free and it just takes minutes. Thank you.